so two things to talk about today, really, just to get started in this next unit. So we're got our iPads put away. We really don't need our iPads if that's what you're doing. Okay. I'm going to trust you, Mr. Gilbert. You better not let me down. All right, so the first thing we're going to talk about today is inverses. Now, to find an inverse of a function, first of all, we need to understand what an inverse is. So let me give you a couple of examples here. Let's say we had the function y equals 2x, and we had another function y equals 1/2 x. Let's talk about some ordered pairs that are part of this line. What would be some ordered pairs that would be part of this line? Give me an example. Give me one ordered pair. 1, 2. Yep, there you go. If you let x be 1, y is 2. What would be another ordered pair? 2, 4. How about -3, -6? So those are some examples here. All right, now let's come over here and let's look at the ordered pairs over here. What if I let x be 2? What would y be? 1. What if I let x be 4? What would y be?
2.
And if I let x be -6, y would be? Now, these two equations, these two functions are inverses of each other. Notice what happens to their ordered pairs. They are flip-flops, aren't they, of each other? So in other words, whatever this function did, it changed a 1 into a 2. This function undid. It took the 2 and changed it back into 1. They undo each other. Inverses undo each other. So let's see. If we had a function like f of x equals x plus 3, can you imagine what the inverse would be? If this is the function that adds 3, what will the inverse have to do? Subtract 3. So the inverse would subtract 3. Now, this is inverse notation. This is read, if you were reading this out loud, you would say f inverse of x. F inverse. It's not a -1 exponent, but that's what it looks like. It is not. It is inverse notation. Sometimes to find an inverse, it's really easy. You did this when you said, look, Mrs. Ford, if f adds 3 and the inverse undoes that, then it's going to have to subtract 3. That's easy. But what if the function's a little tougher? What if the function is 2x minus 5, and we want to find the inverse? Well, there are a couple of ways you can do this. One is you can just think about it for a second. What does this function do? When you feed it a number, what does it do? Multiplies by 2 and subtracts 5. Now, the inverse is going to undo that. Okay, so think of it as a machine. It times this by 2 and subtracts 5. Now, put the machine in reverse. What's the first thing that function's going to have to do if you want to undo what you did? No. Remember, times by 2, subtracted 5. Now put it in reverse. You're going to have to add 5 and then divide by 2. So the inverse would do this. The inverse undoes what you did. So think about it as just putting it all in reverse. Now let me show you something. Put a 6 in here. What do you get if you put a 6 into this function? You get 7. Now put 7 into here. What do you get if you put 7 into here? 6. Is that what's supposed to happen if things are inverses? Yes, it just goes backwards. Okay? Now, that might be a little confusing. That might be more than you want to think about. You don't want to think about, oh my goodness, I got to find this inverse. I don't want to think about all this backwards stuff and everything. So there is an algebraic procedure to find the inverse. So let's go through that. These would be the algebraic steps. which will work every time. You don't have to do them every time, but you can if you want. So first of all, let's write this with a y instead of function notation. Here comes the tricky step. Switch the variables. Now that shouldn't be confusing to you, because what happens with inverses? If two functions are inverses, what happens to their ordered pairs? They get flipped. So if you are building the inverse, you want to flip the ordered pairs. So you're going to change your x's to y's, and vice versa. Now, solve for y. Get y by itself. There are the algebra steps. If you don't want to do it intuitively, when I did this, I did it intuitively. I just thought about it. If you don't want to do it that way, you can go through the algebra steps and come up with your inverse. All right, let's try another one. Let's suppose we have, and we'll do it both ways. We'll do it intuitively and algebraically. 3x minus 2 over 7. Okay, so let's just think about this intuitively for a minute. We want the inverse, okay? So what does this function do? First it times this by 3, and then it subtracts 2, and then it divides by 7, right? If you think of putting a number in here, you would times by 3, subtract 2, divide by 7. So think about taking those 3 steps. Times by 3, subtract 2, divide by 7. Now, put it in reverse. What are you going to have to do first to start undoing that? You're going to have to multiply by 7, and then add 2, and then divide by 3. So intuitively, that should be the inverse. Now, I can check it. Let's pick a number like, no, this is going to involve fractions, but you'll be okay. Let's pick a number like 4 and stick it in here. What do I get if I put 4 in here? 10 over 7. Okay, now guess what I'm going to do? I'm going to put 10 over 7 in here, and what better happen? I better get 4, right? So let's see if we do. 7 times 10 over 7 plus 2 over 3. What happens here? So that becomes 10 plus 2, which is 12, divided by 3, which is 4. Okay? Now, let's go through that algebraically. Let's go through the steps algebraically in case that's the way you want to do it. So here's the original problem. Okay, so what are the steps to finding the inverse algebraically? I'm doing the same problem a different way. Switch the variables. And then simply get y by itself. So you'll times by 7. Add 2 and divide by 3. So we ended up with the same answer. It's completely up to you which way you want to do that. Now, unfortunately, they do get a tad bit tougher. This can't really be done intuitively, because do you see what happens here? When you feed a number into this function, it does the top, and then it kind of steps aside and does the bottom, and then it divides those two. So this one we pretty much have to do algebraically, which means switching the variables and solving for y. Okay, so here's the problem. Everybody with me? Okay, so let's see if we switch our variables. Okay, what do you think? How would we even begin now? I have to solve for y. How would I even begin that? Okay, good idea, Anna. Bring this over here. So that's going to give me 3xy plus 2x equals 5y minus 1. So I just brought this over here. Multiplied both sides by 3y plus 2. And then distributed. Okay, that's a good idea. Now what? Anybody have another idea? Or the next idea? Well, I think we got to keep in mind what our goal is. What are we trying to end up with here? What are we trying to do? We're trying to get y by itself. So let's rearrange things so that everything with a y is on one side and everything without a y is on the other side. So in other words, 3xy minus 5y equals negative 2x minus 1. The goal is to get y by itself. So I'm going to take all the terms with y and put them on one side and all the terms without a y on the other side. Okay?
Can you divide by 3x minus 5?
What?
Can you divide by 3x minus 5?
Okay, I'm going to. First, I better do something else, though, that you're exactly right. First, I'm going to pull a y out of this. I'm going to go ahead and factor a y out since I have them over there. And then if I want to get y by itself, it's exactly what Madeline said. We're going to divide by 3x minus 5. And there's your inverse. So let's run through that again because there's some complicated stuff there. Switching the variables is easy. That's easy. Okay, so what do we do next? After we switch the variables, what do we do? Cleared the fraction. Right? And distributed. Right, then what did we do? Put all the y's on the same side and then factored them out and then divided. Okay. That's a GTQ, guaranteed test question. So not on this test, but on the next one. So let me give you one more, and at your table, would you practice it and make sure you can do it? Let's suppose the function is 4x plus 8 over x plus 3. See if you can find the inverse. That's your goal, find the inverse. I'm going to redo my attendance here since we had some more in. Still no Maggie, still no Carter. Harry came in. Stripe came in. Emma is here. Mackenzie is here. Harry, why does it say Eric?
I don't know.
There's like 50 kids just, and
Yeah.
they were just all like doing it all together.
Okay, do you think she has the right name?
I mean, I wrote my name down on a piece of paper.
Okay, okay. Why is everybody tardy today?
They stopped the bulldozer, they stopped
Yeah.
traffic so the bulldozer could like turn around.
Oh, you mean on 56th Street?
Yeah, they stopped all ways of traffic.
We waited for 20 minutes.
Yeah.
During rush hour, that doesn't make much sense, does it?
You just need to wait like half an hour to do that and then you're fine.
Yeah. Okay, all right, so how much progress have you made? You put a y in here for the f of x, because we don't like that function notation, and you switched your variables, right? Everybody's okay to this point, right? Okay, now what did you do next? Alex O'Malley, what did you do next? And so you had xy plus 3x, because you distributed when you did that, right? Okay? Jadelle, what did you do next after you got that multiplication done? I'm not quite ready to take the y out yet, because what have I not done yet? I got to get all the y's on the same side. So I'm gonna move this over here, and at the same time, I'm gonna move this over here, because I only want y's on this side so that I can factor it out. So I'll have xy minus 4y equal negative 3x plus 8. And then I can factor and what's the last step? Divide. Everybody okay? All right, I want to show you something that, where's my original problem? Did I erase it? What did I start with here?
It's the.
Was it this one?
Yeah.
Okay. I want you to think about something for a minute, and this is good review for the test that we have coming up. What is the domain of this function? X cannot equal 3. So in the original, the domain is x cannot be negative 3. Everybody okay with that? That's a test question guaranteed on the one you're taking Thursday. All right? Now, what's the range of this function? Now, this is a tricky problem, but I want you to think about this for a second. Where is the horizontal asymptote in this problem? Another test question. Y equals 4. And we have a vertical asymptote at negative 3. Okay, and I don't have much room there, so I'm going to redraw it over here. So we've got at 4, we have a horizontal, and at negative 3, we have a vertical. So everybody's okay with that, right? Because that is on Thursday's test. Okay, so if I plotted some more points and sketched this in, you would see a curve that looks like this. Now that should make sense to you because this problem is a fraction, so it is a variation of which of your basic functions? Reciprocal functions. So things are shifted around and moved because of the adding and all that stuff, but that's basically a reciprocal function, right? Now, when I talk to you about the range of this, domain is easy. You crank that out right away, good. When I talk to you about the range of this, how far down does it go? How far up does it go? Every y value is covered except one. What is the one y value that's not covered in this picture? 4. So your range is y cannot be 4 because you got an asymptote there. There's no point that has a y coordinate of 4. Do you see that? They have y coordinates of every other value, but not 4. Okay, so why am I talking about this? Well, I want you to come over here now and look at the answer. You got the inverse. This is your inverse now. Tell me about the domain of the inverse. X can't be 4. Tell me about the range of the inverse. Now think about where would the asymptote be in this one? So if I drew it, it would have a shape like this. The asymptote's in different places, but what would be your range? Y can't be negative 3 because that's where the asymptote would be, right? Now wait a second. What do you notice about the domain and range of the original and the domain and range of the inverse? Does that make sense to you? Absolutely, because what do inverses do? Switch the ordered pairs, right? So doesn't it make sense that what was associated with x in the original domain is now associated with y in the inverse range? Right? Okay, so I'm telling you that because sometimes when you want to find range, it's easier to back your way into it. Everybody in this room should be really comfortable with domain. Right? Everybody should be comfortable with domain. If you can find your inverse, and you can find the inverse and then find the domain of the inverse, what can you tell me about the domain of the inverse? It's going to be the range of the original. So if you can't figure out the range of your original function, find its inverse, and do the domain of the inverse, because the domain of the inverse will be the range of the original. You see what I'm saying? Sometimes I do that. If I have a hard time visualizing it or something, I'll just find the inverse, and then I know what the range is.
Isn't the range just like the opposite of the horizontal asymptote though?
Yes, if the picture has a horizontal asymptote. Not every curve has a horizontal asymptote. I mean, all the reciprocal functions do. All the reciprocal functions do, but not every function in the world has a horizontal asymptote. Right? Okay, so let me kind of show you what I'm talking about with one more. Let's say, this will be kind of an easy one, but let's say you had a function, let's say x squared minus 1. Now, domain here is easy. What's the domain of that function? That's all real numbers. No denominator, no radical, no issue. Now, what's the range of that function? Well, I think this is an easy enough one. You should be able to figure that out, but let's pretend you can't. Harry, get your head up. Let's pretend you can't. You can't figure out what the range of this thing is. Let's find the inverse of this. Okay? What would the inverse look like? Well, we're going to do this, right? And then we will add 1 and square root. Now, tell me about the domain of this. You know what the domain of this is. What's the domain of this? X has to be greater than or equal to -1, which automatically means the range of this one was y is greater than or equal to -1. Now, you probably knew that already because this is a squaring function. This would be a test question. Could be a test question. That's a squaring function. Drop down 1 unit. Does it make sense that the range is greater than or equal to -1? Okay. All right, well, I think I've about talked inverses to death. So we've got one more topic, and then I'll hand your test back to you. The second topic we have to talk about is a new way of writing functions. It's called parametric equations. Let me give you an example here. These are called parametric equations. And sometimes it is easier to write equations parametrically. It's kind of hard for you to understand right now, but certainly when we talk about vectors, you're going to see exactly what I'm talking about. But for now, what in the heck does this mean? Well, pick a value for t. We'll just say let's let t be 0. What ordered pair would be associated with letting t be 0? Let t be 0. What do we get for x? 1. And y? Okay, let's let t be 2. I'm just making up these numbers. What do we get if we let t be 2? 4. So do you see how I could generate a whole table of values here, a whole set of points, by just picking different t numbers? Okay, that's easy enough. What if I didn't want to do that though? So here's my objective. I'm going to draw a picture of this. What's this look like? Well, I could do this. I could keep cranking out, I'm going to let t be -1 and t be 5, and I could keep creating points. I could plot all those points and get a great picture. Instead of doing that, what if I wanted to turn this into a regular equation? Any thoughts on how I might take this, what I have right now, this system of equations here, and change it into a single equation so I could look at it like I've done in the past?
Multiply
Multiply
it.
what?
T squared times 2t plus 1.
Well, you're not, that's not quite right, but you're not totally wrong there either. You're kind of thinking in the right way. Deanna, did you have your hand up? Delaney?
Can you do substitution?
Exactly. And what would you suggest we substitute?
And T squared.
What if we solve for t? What would t equal in that top equation? X minus 1 over 2? Now that's t. Now what do you think I'm going to do? That's t. What do you think I'm going to do with it?
Put in the
Plug
T
it right here. So I'm going to have y equals x minus 1 over 2 squared, which would be y equals, that's a 4. Actually, I'm just going to leave it x minus 1 squared over 4, or 1/4 x minus 1 squared. What is that the equation of? Y equals 1/4 x minus 1 squared. What is that? That's a parabola? Where's its vertex? Moved over 1 unit? Right? This is a multiplier. It's not added or subtracted. This tells me it's moved over 1 unit. So this set of parametric equations just generates that graph. It's a parabola. Okay, let's try one more. There's all bleary eyes out there. Let's find one more. Here we go. Come up with one single equation to describe this parametric situation. Get t by itself, and I don't, which one, it really doesn't matter, I don't think in this case, which one would you like to get t by itself in? The first one? So that would be x minus 1 over 3, is that t by itself, did I do that right? And then what am I gonna do with this x minus 1 over 3 thing? Plug it right here. So y equals 2 times x minus 1 over 3 minus 8. Is this one gonna be a parabola? When I'm all done here, is this gonna be a parabola? Mm-mm. What's this one gonna be? Can you tell? I can't tell if somebody said, if somebody said it or not. What's this starting to look like? A line, yeah, we're gonna have a line. Negative 2x plus 3y is gonna equal what? Negative 26? That's just a line. So these two parametric equations generate a line. I don't know how much you've played with your calculators, but when we come back to this, after our test, so like on Friday, we're gonna get our calculators out and we're gonna graph parametrically, because your calculator will do that. Do you remember on your variable button, get your calculator out real quick, if it's handy. On your variable button, and that's where you type X, remember your variable button? There's another variable on that button. There's X, and that's the only one you've used so far. But what's the other button that's right there on that variable button, right next to your alpha key? What's the second variable on there? T. Guess what? That's what we'll use when we put things in parametrically next Friday, or this Friday. Okay, enough of that. That's a good start. Let me hand your test back. How much time do I have? I got plenty of time. All right, I'll hand these tests back. Have you recollect them?
What about
Santa. that, and I will recollect these.
That's better than I did.
So as soon as you get your paper back, start reviewing it with your people at your table. Newman's not.
My dad didn't sign it.
I got you and right. Because we both have chips.
Madeline, Alex, Andrew,
I did really bad on this test. I didn't know how to do it.
Gary Payton, Yana, Jessica.
Totally know that.
Did you guys not hear?
Those tests,
I have quite got 1.1.
the rest of the 4 hours.
Maybe I'll have all of this. Oh God.
Did you do well?
Yeah. Who beat you? 71.
I just make dumb mistakes.
I don't think I was.
Okay, the test is scaled to 100, but it doesn't have 100 points on it. I can't remember, it was like 20, gosh, it's been so long. It's like 24.5 or 23.5 or 25.5, something like that. So let's say there's 25 questions, 25 points on the test, then every one you miss is really 4%, right? So minus a fourth would be like minus 1%. Okay? All right, let's run through a couple of things that I remember. We gotta get our properties down, kids. Those are like just, that's like nouns and verbs. You gotta know your properties. So the first property is associative because we regrouped associative addition. The second one is transitive, or some of you said substitution, and I let that go because in geometry we do allow transitive and substitution to count the same. And then we have the additive identity. Your vocabulary words, they differed from test to test. So let's see, in your class, vocabulary reflexive, your reflexive property says A equals A, period. That's reflexive. Rectangular coordinates, X comma Y. We live in a rectangular system, it's simply X comma Y. Open interval is all the numbers contained between A and B, but not including A and B. Those are all definitions on your word sheet, on your math term sheet, that were identified as things you need to know. So go back and relook at those if you want to. Always behooves you to try the bonus, even though the bonus was hard and no one got full credit on the math bonus. Always behooves you to try it. How many of you picked up a fraction of a point because you did something on the bonus? Yeah. Just do something that looks reasonably like you know what you're doing, and you can pick up, at least a fraction of a point. Okay, anything else about this? Test that we need to talk about. Those were just some things I highlighted. Did you notice, and maybe you haven't even thought about it, maybe you've forgotten about it, it's been so long ago, but you had a review sheet for this test, this one here. Did you notice that the problems were kind of the same on the review sheet and the test? Think that might happen for Thursday? You've already had one review sheet, you're gonna have another one for homework? Yeah. So I guess what I want you to do is maybe make sure you know how to do what's on the review sheet. I think it will help a lot. All right, pass those up, and let's get our homework questions out. Pass me the test back. These are always available to you to peruse. Always. I stashed them in the closet there. You can come in anytime and look at them. Ask me questions about them, bring a friend in, review them, whatever you want to do at any time. Properties of, is that what that says? I can't even
It's
read
like
that,
y. So
right?
if the graph is like that, y is gonna be all real numbers. The range is gonna be all real numbers. But if it's like
For like the one plus
that,
problem, I do the same number.
if it's like that, then range is gonna be y is greater than or equal to 0.
Is it
Oh,
always have to
I might switch it up completely since I'm not gonna do that, one
I
of the
do.
assignments. Do I do it again?
No, but I was just gonna do the graph it and then
Yeah, do that too.
Okay, all right, so last night's homework.
Yeah.
Who had a question? We are reviewing for a test on Thursday. Tomorrow, we are not coming back to this until Friday. Tomorrow, even though it's a short period, we're gonna spend the whole time just reviewing, okay? So who had a question? Mr. Stripe?
23.
23, and I am back on page 165. 23 says, find the vertical asymptotes, horizontal asymptotes, and state your equation. Okay, so 7x over x squared plus 10. Okay, we want the horizontal asymptotes and the vertical asymptotes. Did I copy that right? Okay. All right, so let's talk about vertical first. Those are usually easiest for us. Vertical asymptotes. What's your thought on that? How do I get vertical asymptotes? The denominator is 0. Now I want you, I know there's a radical down there, but I want you to just think about this for a minute. X squared plus 10. Anyway, that's going to be 0. X squared plus 10. Can that be 0? No. This problem has no vertical asymptotes. The denominator can't be 0. You can't square and add 10 and be 0. So no vertical asymptotes. Horizontal is a little tricky. Did anybody have a thought on that? It's a little tricky. Michael? In fact, it's very tricky. This will not be a test question. This is very tricky. Go ahead.
Oh, I thought it'd just be like 7.
Okay. Okay, why?
Because if you square root of square, it'd just be x.
Okay, so he's saying, you're exactly right. You're so close. He's saying, when I do horizontal asymptotes, I'm supposed to compare the highest powers, right? The square root of x squared is x, correct? So I have 7x over x. So he's saying my horizontal asymptote is y equals 7. Now, does that make sense to you? Because you're square rooting the square. Here's the issue. This is what makes this problem tricky. As long as x is a positive number, Michael, you are right. So if I were sketching this, here's where y is 7. As long as it's a positive number, that asymptote is at 7. But what happens if x is a negative number? I'm putting 7 times a negative number over this, which will be positive. Do you see what I'm saying?
Yeah.
So on this side, the asymptote is negative
So
7.
it's both.
It's both. It's split. Now, that is not on your test. That's a tricky question, but that's what happens. That's what happens on that one.
25.
Okay, 25. Let's switch gears now. That's a cool problem. I like that problem.
Is that what
Um,
happens when there's a radical?
What?
Is that what happens anytime there's a radical on the bottom?
Not anytime there is. If you got a variable sitting up here, that will happen. Now, if this had been x squared, then that wouldn't happen. And in fact, if that had been x squared, there'd be no horizontal asymptote. because then you're 7x squared over x. But as long as if there were a 7 up there, wouldn't happen. But because of the fact the numerator can be positive or negative, but the denominator will always be positive, that's what's controlling that. Okay, so which one did you say?
25.
Y equal, and what am I doing here? Graph the function and state the intervals on which it is increasing. Okay, well, let's look at the function as 1/6 x cubed. That's just another way of writing it, right? Or 1/6 x cubed. Okay, what's that look like?
Q.
So you know what a cube function looks like, right? Now, I didn't add or subtract, so I didn't move it at all. This just stretches it or shrinks it. So I have the same shape, just maybe flattened out a little bit. But that doesn't change, the shape is what controls whether it's increasing or decreasing. So what would you say about this function? Well, it's continuous, yeah, but what about increasing or decreasing? The whole thing's increasing, right?
Yeah.
So from negative infinity to positive infinity, it's increasing.
Okay.
Yeah, that was the question. Where is it increasing? And it's from negative infinity to positive infinity.
What would the graph for 27 look like?
Y equals x over 1 minus x squared.
That's close.
Well, first of all, let's do what we know how to do. Let's put in all the asymptotes and intercepts, and that might give us an idea what it looks like. So, how would you suggest we start that problem? Factor the denominator. And that's going to tell me what? What information is that going to give me?
There's holes. There's no.
There's no holes. Because the only way to get holes is to cancel, and I didn't. So what do these tell me though? I'm going to have a vertical asymptote where x is 1 and where x is negative 1. Because x can't be either one of those things. How about a horizontal asymptote in this problem?
There's 0.
0. Why is the horizontal asymptote at 0? You're exactly right. What's the power on the top? X to the first. What's the power on the bottom? X to the second. Anytime the power on the bottom is bigger, your asymptote's at 0. You can figure that out by simply saying, hey, I need a 0 up there to compare these. Okay. How about intercepts? What happens if I let x be 0? I get 0, don't I? So that's it. Well, that's not much to go on. So what am I going to have to do? If I've got to graph this, what am I going to do? Well, it's something contained in here. What I don't know, Delaney, is I've got different options. It could be a parabola, either up or down. It could also be like a cube thing, though, right? So how will I figure this out? I'll plot a couple of points and see. Yep. I'm not going to ask you to do a complicated graph like that. I may give you this equation and ask you for asymptotes and stuff, but I'm not going to ask you to do that. Tonight's homework, I want you to do review sheet 2. Wait, was that what I signed yesterday? Yeah, today. Tonight's is review sheet 2. I want you to do review sheet 2. You're eating a container of ice cream?
I was.
Okay, is it gone now? Is it going to melt?
No, I'm not sure.
Oh, okay.
But why on this problem, since there's big part squared in the denominator, well, I sort of, but in this one,
Well, because this isn't really an x squared. That's really an x because it's being square rooted. That's the difference. Okay, I'll look at your test and adjust your score. Is that what you're hassling me about?
Oh, no, I have to do this on Thursday. Yeah, I
Oh,
probably,
that's test day.
I know, that's, because Maggie and I are in the same parametric class, so we're both,
they say you'll do that by next period, so why don't you come next period that day and take it, okay?
Okay.
That'll work. That'll be perfect.
Fun Mackenzie, happy birthday.
Thank you.
What about before school on Friday, is that?
Well, I had to go, so I can't get it.
All right, if you
I
forget,
got sick on
Mackenzie,
Thursday.
if you forget, you'll come during fifth period lunch, you are in big trouble, okay? Because I'm not gonna, this last time, because of all that funeral stuff, but it took me 2 weeks to get stuff made up, I'm not doing that again,
Okay.
okay? So if you forget, you're in trouble.
Okay, thank you.
Now I gotta fix Stripe's test score, because that was a mistake.
I was with her because she tried to be funny. I was like, you know, she go and hide her. She go, you want to do something. Every time she said I want to do something, I literally do. I would leave her. Only thing that scared me is how I was. She was like,
What are you all stewed about, Maya Brownlow?
I left my friend at Steak and Shake yesterday. I got to do, I drove off on there. And I left it. But I came back after like 4 seconds.
Did you forget, or were you
No.
mad at her?
No. She just says like, you know, she like, oh, you want to do it, so I just did it because she was like, you signed this for me.
Oh my Lord, child.
Okay, I'll be.
Actually, yes.
That was just the
You like went back to this interview.
That's funny. I think you got. I haven't even gotten over like